Unfortunately, these flowcharts don't actually show the code that goes with them, so they may not be as useful as they would otherwise be otherwise. You know, we kind of did some like this in class, and then your homework was one like this. So I've redone this flowchart to have some code next to it so that you can compare it to your homework. But this is one of those that has elifs in it, which stands for else if. So it asks for them to type in their grade. If their grade is greater than 90, we print A. Notice that all of our if statements are in diamonds. You can't stick the word if in a rectangle or a parallelogram or whatever and have it, you know, be counted as an if statement. Yeah, I didn't make the shapes up, I just have to grade them that way. So this one, you know, if the grade's greater than 90, it prints A, and then there's a line going all the way down. Every shape has to have a line coming from it, going to the end or going to wherever it's going to go. If you kind of have a dangling shape, like if you have a yes line and it comes out to here and then it stops there, that's not right. You need to show what's going to happen next. And that'll be a little bit clearer when I pull up the example that I've made that looks just like the code that we did for our flowchart. I mean for our assignment. Elif grade is greater than 80. Print B. So if that's true, we print B and we skip down to the end. No. Elif grade is greater than 70. Yes, print C. And now if none of these are true, there's an else statement at the bottom that catches, you know, the error case that none of these were true, in which case we print F. So all flowcharts need to have a little box up here that say either start or the name of the function. You know, if you've defined a function, you can put, you know, the name of your function there. You could conceivably put main there, but right now we're not actually putting our code in a function called main. We're just putting a comment there that calls main. And every one of them needs to have a stop statement. Okay, let's go look at the better example. There's one called if, elif, else flowchart. And the real difference here is that it just has the source code as well. So here's our code. We could type this in, but I'm not really, I mean, if you really felt possessed to, you could. By the way, don't type in the code for one of the flowchart assignments and then just upload the code as your submission. The point of these assignments is to actually draw something, not to type in this code. You know. So if you send me a PY script, you're not going to get credit for it. You could add it in with everything else and that'd be fine, but you know, just don't turn that in by itself. Print, what sound does your pet make? Sound is equal to input. If sound is equal to bark, print dog. Yeah, takes a real psychic to divin these things out. Else if sound is equal to meow, print cat. Else if sound is equal to moo, print cow. Really? Else print I can't guess. So this is a series of if-else if statements. You know, if it's one thing, do something else. Else if it's something else, do something else. If it's moo, print cow. And then finally, at the end, a catch-all else, in case none of these others were true, that says I can't guess. So here's the flowchart that corresponds to that. What sound does your pet make? Input sound. If sound is equal to bark, print dog. If sound is equal to meow, print cat. If sound is equal to moo, print cow. Else, if none of these are true, print I can't guess. Now these are kind of done to my slightly modified rules of flowcharting. In standard rules of flowcharting, you don't put the words if and elif in your diamonds. You can leave those out. Also in standard rules of flowcharting, you don't use the word else there. You use the word false or no. But I think that this makes it easier to code from. If we were able to pull up both of these side by side on the screen, maybe we can. So there's our code. Let's see if we can get this to work. There's our flow chart. Print what sound does your pet make? Sound is equal to input. If sound is equal to bark, print goes over there and it prints the dog statement. If that's not true, we drop down here. elif sound is equal to meow, print cat. elif sound is equal to meow, print cat, and then under there there's another diamond. elif sound is equal to moo. So I'm putting the elifs here just because that appears in the code over there, and that would make, tying the two things together in our mind a little bit clearer. If we were doing this as part of our real job and it was going to go into another language, they might be puzzled to see these elif statements, since that is specific to Python. Other languages do have an else statement or an else space if. And then lastly, if the meow wasn't true, what's going to happen? What happens after we check to see if it's a meow? Well, we check to see if it's a moo. If the moo is true, we print cow. Else, none of these were true at all. So we have else, print I can't guess, done. And my rules of thumb is I always make the if true conditions, the if cases go that way, just like we indent. But I make my else go the other way because that makes it really stand out. You don't have to do that. And you don't have to try to struggle to fit it all on one page. You can make it stretch across 20 pages, and when you save it as a PDF, it'll stitch it all together. It'll be cool. Okay, I want us to all flowchart together another program. We could type this program in. I'm not sure that that's necessary to understand it. But if you go back to contents, and you look at the guessing while loop, long time ago in the book, Head First Python, we did a guessing game. This is a slightly modified version of it. I am going to go ahead and type it in rather than just jump in and do the flowchart. And I recommend you go ahead and type it in as well, just to keep in practice. So pop open Python, do a save as, save your game, not in the Python directory, but somewhere else, and call it Game2 for guessing game 2, just to not overwrite your prior one if you had one. Okay, so this one's going to make use of a predefined function that we're going to write. When we define a function, this one's going to be a fruitful function. It's going to return a value. So we're going to call this ask. This function calls ask. Let's first put, program by a programmer. I'm going to put my name up there, and I'm going to say what this is. This is a guessing game. All that ask does is print, please guess a number, get some input, and then return that input. Now I'm going to run it even though it's not going to do anything at all, just to check the syntax. Make sure I didn't leave off a colon. All right, it didn't do anything, but that's good. Didn't croak out an error. All right, now the way the program is going to work is it asks for a number. If the number is not equal to our favorite number, it increments the number of tries so that we can keep track of how many times they've tried, and then ask them for a new guess. So we need a value to hold our favorite number. It'd be much more fun if this was random, but I'm just going to hard code 256. That's the number we're trying to match. And tries is equal to 1. At the beginning of the game, they're only going to have tried once. Now let's get their input. In is equal to ask. When we do that, it calls the ask function. The ask function says, please guess the number. Oh, I forgot a statement. We need to turn that string there into an int. We could fix that in one of two ways. We could do a conversion there, or, well, yeah, that's the best way. So before the return in statement, add the statement in equals int parentheses in. So I skipped that one, so I'm going to put some comments on it to show that, we need to make sure you get this in here. Now we're going to have a while loop. A while loop keeps repeating the code until the condition is no longer true. Here's our syntax. While n is not equal to 255.
Is it 55 or 56?
Oh, I'm so sorry. While n is not equal to fave. This code in the upload is incorrect. I'm going to have to fix that. My mistake. In fact, I'm going to cover that up so I don't make the same mistake again. Okay, so if it's wrong, we need to print an error message. We could just say, wrong, guess again, but that's not really enough information. Instead, we're going to tell them if it's too low or too high. If n is less than fave, colon, print too low. Else, colon, print too high. And you just have to make sure that you get all your, your tabs right. So we've told them what's wrong with their guess. Now we need to get a new value to test. N is equal to ask. We call that function again. And then we need to increment the number of tries we've made. So n plus equals 1. That adds 1 to the number of tries. When they finally get it right, we're going to tell them how many tries it took. Print success. Tries equals, comma, tries. Something like that. And now we're done. Of course, I haven't run it to make sure that there's no syntax errors and to make sure it runs correctly, but please guess a number. $100, too low. $300, too high. $250, too low. $260, too high. Now see, this would be a lot more fun if it was a random number. $255, too low. $256, success. Took 7 guesses. They weren't really guesses if I knew what the number was, but I was just testing it out. Okay, so that's an illustration of a while loop. Sorry. A while loop is one that repeats as long as its conditional is true. Like a gate there. There's a gatekeeper who won't let you in unless this condition is true. And as long as that condition is true, you're stuck in there. Finally, if this ever becomes false, you're allowed to leave. If this wasn't true to begin with, then you skip the code. You're not allowed in there at all. Just like an if statement, except the while means that it has to repeat rather than an if, which just runs once and then drops out. Okay, so hopefully you can get that all typed in and it'll run for you. After you've gotten it to run, let's go ahead and flowchart it. There's going to be 2 things to note about this flowchart. One is that we're going to use a predefined function. A predefined function will be a second flowchart on our flowchart diagram. It looks like our main one, but at the top of it, it's going to have a define statement, and at the bottom of it, it's going to have a return in. So in the little pill-shaped ovals, at the top it'll say define ask, and at the bottom it'll say return in. And then we will use that function within this other one. So go ahead and log back in to Lucidchart. And if you don't have a Lucidchart password, go and look at D2L. There's a link in D2L to where you can register a Lucidchart account. And since it'll be attached to my name, it won't be a demo account. You'll be able to do everything you want to with it. Or if you like Visio and you've used Visio before, feel free to do that. All right, I'm going to go ahead and load up Lucidchart. I know that that's going to make it impossible to finish typing this in. So I'm going to Lucidchart. I typed in lucidchart.com. I click login. And then I'm going to click plus document because I want a new document after you've logged in. Okay, so the first thing I'm going to do is do the ask function. That's a predefined function in terms of flowcharting. It's not called a predefined function in or predefined process in terms of flowcharting. That's not what Python calls it, but you know, flowcharting is a bigger topic than just for one language. So I'm going to grab my little pill shape because every flowchart has to stop and begin and end with one. But instead of just saying start or stop, it's going to have the name of the function. So def space ask. I could even put the colon there to make it look way too Python-y. There we go. Now what does what does the ask function do? The first thing it does is say, please guess a number. So which box do I use for input and outputs? I use the tilted parallelogram, or as Lucidchart calls it, the data I/O. Print, please guess a number. If you ever want to embed a carriage return, you can hold the control key down and hit enter. I'm just going to stretch the box real wide. Draw a line between them. Okay. Now I need to convert that to an integer. Why do I have to do that? Because the input function, well, I haven't even called the input function yet. So that'll be the next thing I do. Input is also a data box. Parallelogram. So input space in. I could make it look exactly like Python syntax and make it say in is equal to input, but that's close enough. And what I mean by that is I could make this match exactly the line. I could say in is equal to input parentheses in parentheses. And so I'm kind of mixing using pure Python syntax like I did in this define here with more generic programming terms. And so I'm only going to use the Python specific stuff if I think that it actually aids in the understanding of the flow chart. And in this case, I think a print statement and an input statement are good enough. But you know that you can't type input space in into a Python program. Instead, you have to say in equals input. So don't get fooled. If I give you a flowchart that says input space in, you have to turn that into valid Python, and then it's going to look like that. All right, now I have to convert that to an integer because input returns a string, and we can't do math on a string. Now, a conversion or something like that, we're going to call a mathematical process. So I'm going to use a rectangle rather than a parallelogram. And here I am going to use a specific line of Python. But I could instead use text. I could say convert into int. But instead I am going to use the exact Python syntax. And it's entirely up to you when you want to switch between being vague and using English type language and when you want to put in programming terms, because the flowcharts are for us to use. Really, as long as you have the shapes right and you have the lines going in the right directions and stuff like that, I'm going to probably give you a really good grade on the flowchart. All right, and now we need to return. We have converted in into an integer, so we need a return statement. What does every flowchart begin and end with? The pill shape. The same is true of a function. So I'm going to put return space in. Okay, so that's what my function looks like. It's not the main code. It doesn't have a start and a stop. But this is something that we're going to call in our code. What I would really like to do is to grab all this stuff and move it to the right. So I'm going to do that. I'm going to anchor this, and I'm going to drag a box around the entire thing. and I'm going to drag this over here. And the reason I'm going to do that is because I like for my main flowchart to be on the left, and then the functions for them that they call to be shown to the right. However, yours doesn't have to do that. There we go. That's our ask function. And I like to color code our functions, but I'm going to leave that off for now, especially since people tend to like to go up and play with the themes and stuff, and that would erase all the colors anyways. Okay. Now I need to actually flowchart this part of the program. Everybody got this half pretty much? If you didn't, I can leave it on the screen a little bit longer. I'm hoping that as I blather, it takes me longer to draw it than it does you, but that may not be the case because you're not used to the program yet. Need more time?
How do you take an arrow off if you accidentally put
You select the arrow and then hit the delete key. Very good question. And if you can't select the arrow because your shapes are too close, then hold the control key down and zoom in with the mouse wheel until everything's really big, and then you can finally grab it. You know, sometimes things wind up so close it's hard for it to distinguish what you're clicking. But the control key and then zooming with the mouse wheel zooms way in. And then you can delete it if you need. All right. Let's do our program now. I'm going to put a start. So here's my start box. Now start's not an actual line of code in the program. It's just a you are here. Every flowchart needs a start and a stop. But then I have something here that actually is code. It says tries equals 1. So I'm going to make a variable, and it's going to be in a, this is a mathematical operation, so I'm going to put it in a square box. And I'm going to say fave is equal to 256, and there's no reason why I can't put both of these things in the same box. So I'm going to go ahead and do so. Holding the control key down, I'm going to hit enter, and then I'm going to put tries equals 1. Oh, there's something I need to mention. For some of y'all, if you look and you get a grade of like 1 for an assignment that you turned in that was a Word document, it's probably because I couldn't open the Word document. And I'll show you why. I'll talk about that in just a minute. Okay, so I've done these two things. Now I'm going to call my ask function. This is a function that we wrote, so we're going to use a different symbol than we would just to do a little procedure like this. We're going to use the box with the extra bars on the left and the right called a predefined process. And that indicates that we're calling something that's shown elsewhere in our own flowchart code that we wrote. So n is equal to ask. You kind of get the difference here. This is just Python code that's performing math, but this is special code that's calling our ask function. So that's why we give it a special box, because we are denoting that this ask function is coded, is illustrated somewhere else in our flowchart. If you have a box like this with lines going up and down, but you haven't flowcharted it somewhere else, then it's incorrect, because that's what this means. If you put the vertical bars on it, it means that it's a function that you have drawn a flowchart for somewhere else in this document or on another page. Okay, once we get n is equal to ask, we enter our while loop. Now a while loop looks just like an if loop according to flowcharting rules. Not an if loop, an if statement, a decision box. And you can leave the keyword off, but I don't like leaving the keyword off. I like making my flowcharts as understandable as possible. So I'm going to put the word while there. While n is not equal to fave. And if that's true, we have this error condition where we need to come and start executing this code. So we're going to run off to the right and start doing stuff. So I'm going to draw an arrow going over here. And what's the first thing after that while statement? It's an if. That's another decision diamond. So if n is less than 5, we're going to print too low. Now I'm going to try to show some hierarchy by, putting some, by dragging this one below the other one and making the line go up to the top like that. Now if that's true, we're going to print too low. So from there I'm going to draw another line, but it's going to go to a print statement, which is a tilted parallelogram. Print too low. Now this one has kind of gone over and started to intersect with my other flowchart, and I don't like that, so I'm going to try to fix that. I'm going to zoom this thing in to cover up the code now. The flowchart's getting complex enough that I need the additional space to make it make sense. And with that in mind, this ask function I can drag even further over to the right. So I'm going to zoom out by holding the control key and scrolling the mouse wheel out. I'm going to grab the entire ask function and just move that way over there so he's not in our way anymore. Okay. We have an else statement as part of our if statement. And I usually make my else statements go off to the left. I may regret trying to make it do it like this. Yeah, I probably will. So that word no, I'm going to change to the word else. You don't strictly have to do that. Under there, I'm going to put another if box. If, oh wait, no, there's no second if statement in my code. See, that's why I should keep my code up while I'm looking at this, because the logic is if n is less than 5, print too low, else print too high. Okay, that actually is easier to flowchart. I need to delete my decision block though, and my else statement is just going to go to another print box. What's the print shape? It's the parallelogram, and that's going to say too high. Now those things need to join back up together. You could use a little circle to make them join together, or you can just put the next line of code. I think I'm going to go ahead and put the circle there. But I'm going to take that A out. Now I'm going to make a line go to that one. I'm going to make a line go to that one. That's just indicating that that's the end of the entire if structure. That's not a line of code. And then I'm going to shrink the circle down a little bit because that's obnoxiously large. And of course you can take 20 hours drawing your flowcharts and making them look too pretty. Okay, so there's the logic so far of my program. Start. Faves is equal to 256. Tries is equal to 1. N is equal to ask. We ask the user from their code over here for that value. While n is not equal to fave, well, they didn't get it right, so we have to tell them whether it's too high or too low. If it's less than fave, we print too low. Else we print too high. Now we need to get another guess. So we're going to repeat our function call, our predefined function call. So underneath that circle at the bottom of our if statement, we need another box that looks like this. And if it looks like that, I can just copy and paste it. So I'm going to select that guy, choose Control-C for copy, and then hit paste and drag it under there. Now you could just draw it again. There's nothing wrong with drawing it again, but if you can, Control-C for copy and Control-V for paste, bless you. And we need to increase the number of tries. so that we can tell the user how many times it took before they finally guessed it. Now that's another mathematical operation. So that should be in a rectangle. Tries plus equals 1. And I try to squeeze stuff together as closely as possible, but the only reason I'm doing that is so I can fit as much of it on the screen. You're not hampered by that limit. Okay, I'm going to go back and check my code and make sure I haven't forgotten something. We called ask, we incremented tries. Now we need to loop back up to the top. Since it's a while statement, it loops. You can draw your loop pretty much any way you want as long as you indicate that it's going back to that while diamond up at the top. So I'm just going to take a line, draw it off the side of here, and make it go all the way back to that while box. Now that looks really ugly. We can take some time to fix that if we wanted to. Or we can make it go the other way. I think that's what I'm going to do. No, what I'm going to do is I'm going to leave it like that, but then I'm going to turn it into a square right angle line so that I can stretch it out. The way you do that is next to the pin shape, there's one called edit line. So if you select that curve and you choose edit line, you can say I want it to have right angles. And once you get it in right angles, you know, you could drag it and it looks better. Okay. So we're stuck in this loop until they finally give us a good guess. And a good guess is defined as where n is equal to our favorite number. When that's finally true, when n is no longer not equal to our favorite number, we fall out of our while loop and we print the number of tries and we're done. So again, it's up to me to decide how I'm going to code this, where I'm going to put the boxes. What does our code do? If we print success, tries is equal to. So I'm going to draw a line out of the while loop that comes down to here somewhere. And I'm going to print a success message. And then underneath that, I'm going to print the number of tries. And I could put all that in one box if I wanted to, because it's all in one line of code. But and then I need an end, a stop. Now I know that's zoomed way too far out for you to read the individual boxes, but I'm doing it just to make a point. Did I have to put this stuff underneath this thing? No. The only reason I put this stuff underneath this stuff is because that's how it looks in the Python program itself. You know, you have a while code, and then you have some indented code, and then you have some unindented code, and this is the unindented code. And I try to make it so that all my unindented code lines up in a row, but you don't have to do that. The flowchart is just to map out the logic. So if this looks kind of stupid, then I could grab this and I could mush it up so that it was next to this code, you know. You can put the boxes anywhere you want to as long as the arrows connect them appropriately. Everything needs an arrow between them, and I forgot to do that here, so I will fix that. All right, I guess I'm going to zoom in right here. I'm going to grab this print box and this print number of tries equals box and this stop box and push them up a little bit so I can try to get the while loop worded in here at the same time. There we go. That's the end of my program, including the loop including the line that goes all the way up from tries plus equals 1 all the back up to the while statement. So if you were following the logic of the program, it's pretty easy to figure out what the program would do. It may not be easy to figure out how to code it, but the logic should be clear. We get our guess in. If our guess is not equal to our favorite number, if our guess is too low, we print too low. Else, we print too high. Then we get a second guess, or another guess, and we add one to our tries counter. And then this line indicates that we go back up to the while condition again. Now this isn't a command. This just means that we stopped indenting our code there. And so it kept repeating. This is the code block that is underneath the while statement. So all of these lines should be indented, by one indentation underneath that while statement. Once the code stops being indented, that's the end of the while loop. And we have those 3 lines. So comparing that to this, I know can't quite get it all, but I guess I'm going to zoom out. It's pretty close. Yeah, there we go. Now we have it all. Erase the code. You should see a 1-to-1 correlation between this code right here, starting with fave and going down to print, and this. Fave is equal to 256 and tries is equal to 1 is right there. That's our predefined function. N is equal to ask. We ask the user for their number. While n is not equal to fave, so we're going to keep looping until they finally get lucky enough to type in a good number. So we have our while statement. Everything after our while statement is indented until we exit the code block for the while statement. We stop indenting to indicate that this code is not part of the while statement. So all of this is indented. That's why I made it go to the right. If n is less than fave, print too low. Print too low. Else, print too high. N is equal to ask. N is equal to ask. Tries plus equals 1. Tries plus equals 1. We stop indenting, which means that we're at the end of the while loop. So that's why we have this line going all the way back up here. And then, since we are done with our while loop, we have this print success. Tries is equal to, and I could have put those 2 print statements in one box. Okay, I'm going to walk around, look on y'all's screen, make sure you don't have any questions, or if you need me to zoom in anything, whatever. Okay, this one, do you have the code? It says, please guess a number. Yep. Back here. Anybody go to Medieval Fair in Norman this weekend? I wanted to. I enjoyed it. It was amazing weather for once. It's fine this way, but you can do that now. And to drag it, it'll be careful. You probably might override it, which you already have. So. Save our documents. Now, as a final touch, what I'll sometimes do if I'm making an illustration to put in homework or whatever is I will color code the ask definition and then call to it. And what I mean by that is if I scroll over here and find my lonely ask function over here, I'll give that ask box a different color, that oval a different color. And you do that with the little paint bucket sign. I'm going to give it a light yellow. And then everywhere I call that, I'm going to give it the same color. And you don't have to do this. You know, you're playing with themes and you're making all your boxes black or green or whatever. You don't necessarily have to do this. But the reason I'm doing this, so the reason I do this in assignments, is that it makes real clear where that function is called, you know. Not only does it have the vertical lines on it, the bars to indicate, you know, that it's a function elsewhere in this code, it's even flowcharted. And if I had several other functions on here, one of them might have a blue box, you know, a blue pill up at the top. And the other one might have a red, and the other one might have a green. You can do that if you want. Okay, so that's our while loop. So now I'm going to write a little program that I'm going to want y'all to flowchart on your own time. It's going to still use our ask function, but I'm going to change it slightly so that it doesn't say please guess a number to please enter a number. So please enter a number. Now we're going to ask them for X and we're going to ask them for Y. Print enter X, and then in X is equal to ask. Print enter Y. You don't have to type this in. This is code that's going to be given to you in your homework. Y is equal to ask. While X minus Y is not equal to 0, nah, that logic is too much. While X is not equal to Y, print numbers don't match. Try again. Now this is really stupid, isn't it? We're just asking them to type in both numbers, and then we're asking them to enter them again. So print enter X, and then get X with the ask function. Print enter Y, get the ask function. And that's enough. We're not going to even have a counter. There we go. Print you entered matching numbers. It's a singularly useless program, but it indicates, you know, I mean, it's just a problem, you know, just like in soccer, running around or bouncing things on your head. You know, you do the simple stuff first before you get out on the match and actually do the things. So this will be called Flowchart Me. I'll give it a better name in a minute when I actually upload it. Can I print this as a PDF? Probably not. No. Okay. I'm sorry, was there a question?
No.
Okay. So this will be assignment 6, flowchart, while loop. I guess I should run it to make sure the code works before I get so high and mighty as to actually post an assignment. Please enter number 5. Please enter number 6. The numbers don't match. Try again. Enter a number 8. Enter a number 9. Numbers don't match. Okay. 5, 5. You entered matching numbers. Yay. Okay. So the program is actually good code. Using Visio or Lucidchart, draw a flowchart for this program that uses a while loop. Okay, this is an excellent example of what I needed to warn y'all about. And Karina, I think this got you.
Yeah.
So I hope you still have the files. If you have Microsoft Word open, you'll see notice that I have a file here. I can't really zoom in, unfortunately. I don't think Control Spin Wheel works here. But I have a file name that says if something something dot dot. That's the good file. But I'm editing it, so it's got a version that has a squiggle, a tilde, and a $ in front of it. If you submit that one, that's the wrong one. That's just some temporary file it's using. Notice the difference in size. The actual file has 175 kilobytes. It's a big file. The temporary file is just 1 kilobyte long. Who knows what it's got in it, but it doesn't have the text that you want to upload to me. So never upload me a file that has a $ as the first 1 or 2 characters of the name. The best thing to do is just to exit Word completely, and then it'll remove that temporary file. So if you exit Word before you upload your assignment, you'll be better off.
I have a question.
Mm-hmm.
Just because I didn't know we actually had outside, I forgot I didn't know your name was Karina. On my thing, you put good job, Karina. That's, you got my work, right?
Did I give you the wrong name on yours?
Yes, that's why I was like, okay.
What did I do? Okay, I'll look at that. I'm sorry about that.
That's okay. Just wanted to make sure that we
Yeah.
were good.
Everybody on that side of the room is named Karina. I'm sorry. That's just the way it is now.
It's a good name, not to say. Well, hers Karina, I'm Marina.
Right. I know. My mistake. I'm sorry. And I know that.
In my files, though, it doesn't have it saved as a as a $.
Let me look. Right, but if you actually go and look at the D2L.
Yes.
Click on the submissions. Yes, VFA. Click on the thing that says, yeah.
I can't believe that left for once.
That was hilarious.
Well, that's the homework assignment, that's not your submission. Okay, so click that thing. Hopefully it'll show you.
But no, you didn't say that. She was like, what quadrant is it being?
Oh,
Dude.
So this is the one I just submitted.
That's the one you just submitted, but that's the one that you have to
Okay.
voice. Yeah.
And just to let you know on your notes now, I'm just turning them late. So.
Okay. All right. As long as you're getting them done. But more if you get it done more quickly. Is that okay? That makes sense?
Yeah.
All righty, okay. All righty, so if you look, there's a homework assignment now for the while loop flowchart. We may as well make a inbox for the flowchart you just drew. Hij, so this will be K. Flowchart for while loop guessing game. So as a reminder, how to get this file to me, go into Lucid Chart. Hopefully you've given it a name. If you haven't given it a name, then it should prompt you when you type save. Call it Flowchart 2 or guessing game or whatever you want to call it. And then you do file print. And hopefully that'll bring up the PDF dialog. And you can give it a better name than that PDF blah 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 series of numbers, or you could just leave that name, but you won't be able to find that file later if you give it that name. So I'm going to change the name of it to Flowchart 2 Guessing Game. Save that and upload that. So you may as well give me both the PDF and the Python script. If you didn't type in the Python script, that's cool. Just give me the PDF. What I really want is the PDF. So on days when we do in-class assignments, I usually take roll based just on the fact that you uploaded something. So upload something, even if it's a text file that just says, I didn't know what the heck you were doing. Alrighty, so where were we in terms of our lecturing? Okay, so we're done with the fruitful function. And I know that some of y'all are probably tempted to go ahead and work on the homework assignment that I just posted right now. I'd kind of rather you actually listen to the lecture as is, rather than work on that, because you could work on that on your own time and it really won't take you very long. But if you're distracted and not listening to my lecture, then that's not quite as cool. Okay, so iteration. Iteration is the idea that you want to automate repetitive tasks. What does that mean? Well, repetitive, repeat, over and over and over. You know, the earliest computers were mechanical computers that were hand cranked or whatever, and they were written, or they were manufactured in order to perform calculations, like to create tables of logarithms. Because in olden days, you know, you didn't have your little handheld calculators or whatever, and if you wanted to multiply 3,247 by, 89,000 or whatever, that could take a long time on a piece of paper. You could do it, but long division is even worse. Long division is actually a horrifically cruel thing. But if you have a logarithm chart, it's real easy. You look up the logarithm of the number. You look up the logarithm of the number that you're dividing by, you subtract one from the other, and then you look up that result on the logarithm table and you get your result. So if you have tables of logarithms, you can do long division really, really quickly, which was really good for the scientists of the 1800s, in the 1700s and the 1900s. But you'd want to do that over and over and over so that, you didn't have some, poor idiot doing long division for, 15 minutes in order to just write down one number on a table in a book, and then keep doing that. Whereas if they had, some kind of calculator that they could program that equation into and then iterate a crank of it and then write down that result, they could crank out a book full of logarithm tables very quickly. That's a repetitive task called iteration. Iteration is the act of repeating a series of statements over and over. Because iteration is so common, Python provides several language features to make it easier, chief of which is the while loop. So also there's the for statement. You will be using those most often. It says you use the for loop more often than the while loop, but I say you use while loops just at least as often, if not more, in this language and other language. So to refresh, in order to iterate, usually we have to have some assignments up at the top. Assignments are when you copy a value into a variable like that. Airtime remaining is equal to 15. And then you can reassign it. Airtime remaining is equal to 7. These are assignment statements. We're copying a number into a variable or any value into any other variable. You do that with what's known as the assignment operator, the equal sign. So here, this is a pretty simple program. It says airtime remaining is equal to 15. Print that variable. Prints 15. What do you know? Airtime remaining is equal to 7. Print that variable. It prints 7. And as a reminder, if you're assigning, you use a single equal sign. But if you have a while or an if statement, you use a double equal sign because this does comparison while this does assign, copying a value. If you try to mix them up, Python won't let you. Some languages will, to disastrous results. Updating variables. Updating a variable is when you perform some calculation like that involves a variable and then you store it back into itself. So here, n is equal to 5. Then here, n is equal to 3 times n plus 1. That means that we want to store an updated value of n back into itself. So if n is equal to 5, what is the value of this expression? 3 times n plus 1. I heard a 16. Anybody second that? No one else is looking at the screen.
Sounds like 16.
Yeah, 16's right. Okay. And so this calculation comes out to 16, and after that statement executes, the value of n has changed. It has been updated to a new value. If you try to update a variable that hasn't ever been assigned, if you try to access a variable that hasn't been defined, you'll get an error. If you say w is equal to x plus 1, but you never gave x a value in the first place, you'll get an error. X is not defined. It's like saying hello to a name of a person that's not even in the room, that they're not there to hear it. So, before you can update a variable, you have to initialize it. You can't say run scored is equal to run scored plus 1 without this statement in front of it. Because if you don't know what run scored is, if the computer doesn't know what run scored is, how could it add 1 to it? So you always have to assign a value to a variable before you can use it in a calculation or before you can use it in an update. And what is an update? It's just a fancy form of a calculation where you store it back into itself. This is a very, very common update. Add 1 to itself. That's called incrementing. It's so common that it's got its special name, incremental change. Incrementing is adding a value to it over and over and over. Decrementing is subtracting a 1 from it. And this is so common that it's got a special syntax, which we used when we did tries plus equals 1. You can shorten runs underscore scored is equal to runs underscore scored plus 1. You could just say run underscore scored plus equals 1. And that does the same thing. It updates that variable with an incremented value. It adds 1 to it. Okay, so I don't think we did much of this in the preceding lectures. I must have just skipped past it. But they're using a for loop in order to iterate what's known as a list. And what's a list? A list is a series of values kind of like this. Names is equal to, and to make a list you have to put your list of values inside square brackets. Joe, Bob, Sally, Mary. All right, so if I print names, it displays the entire list. But if I want to do something, like if I want to print out each name, or if I want to print out hello Bob, hello Sally, hello Mary in turn, I can use a for loop to step through that list. And so the syntax of that is shown here in the for, and it's got a variable name here. That variable name isn't really important, except it needs to not be the same name as your list. So I'm going to say for name in names, colon. That syntax may look a little bit weird. I could choose any variable there for x in names. Since this is our list of values, I'm saying for every value in the names, I want you to copy that into x and then do something with it. Here I'm just going to print out hello followed by their name. Print hello, comma, and then x. Ew. I put the comma in the wrong place. And since I'm doing this in interactive mode, it means I have to type the entire thing again. For x in names, colon, print hello, comma, x. And now I'm going to stop indenting, and it's going to run that command right away because we're in interactive mode. And it prints hello Joe, hello Bob, hello Sally, hello Mary. So this is our list. I stored it in a variable called names. Some languages call this an array. This is an array of values. It's a list of values. We can process them item by item with a for loop. We're just saying that for every value in the names list, print that value out. And I had to have some variable, in order to hold that temporary name, so that it could print out Joe, Bob, Sally, and Mary. So I just chose X. Usually I'll choose something a little more meaningful, like the word name. If I was going to do that, for name in names, colon, print goodbye, comma, name. There we go. Now I'm going to stop indenting, and it's going to do it. Again, print Joe, Bob, Sally, and Mary. So that is a list. And a list can be a list of numbers. It can be a list of strings, like those names. It can be a list of turtles. It can be a list of any kind of data that Python supports. So that is an illustration of using a for loop. I need to copy this and paste it and clean it up later as part of our daily notes. Okay. So this is all part of chapter 7, iterations. And this example is iterating through a list. I'm going to make a couple more examples. What if I have a list of numbers? Numbers is equal to 1, 2, 5, 10, 20. That is a series of numbers. A list of numbers. Python comes with a couple of functions that you can use on that. Like, what if I want to know what the minimum is? Minimum of numbers. Well, the minimum was 1. What's the maximum of those numbers? Now, this is not iterating as we wrote it, but you can be sure that behind the scenes, the built-in function called min has to step through every value and find the largest one, or the smallest one. There we go. So the max value of that one is 20. If we want to sum them all up, we can use a sum function. So sum numbers. Like that. There we go. It added all those numbers. If we want to write a loop to sum them ourselves, we can do that. I would create a variable to hold the result. I would give it the value of 0. I'm not going to use the variable name sum because that's a function name, and I don't want to erase that function. So I'm going to use the word tally. And then for every x in numbers, or for every n in numbers, for every whatever variable name I want to call it in numbers, tally is equal to tally plus x. And now I'm going to stop indenting so it'll actually execute that line of code. And now I'm going to print tally. Oops, print tally. And it prints 38, which is the same thing that the built-in function sum did. So maybe you can see why this is the same as doing that. What this does is for every number in the list, copy that one of those numbers into X and then add it to our tally. And keep doing this until it is stepped through every one. So first X is equal to 1 and that gets added to tally. Then X is equal to 2 and it's added to the tally. 5, 10, 20. And then it is done with the list so it exits the for loop. And we can print out our tally and find out what our tally was. So those are two examples of using the for loop to do something. And that's a good place to stop. So like I said, if you didn't get full credit on the flowchart, feel free to revise it, resubmit it. And I will see y'all Wednesday. Are there any questions?
When is the homework due?
I am sorry, pardon me.
When is the homework due?
This one's going to be due a week from today. Or a week from yesterday, actually. Sunday night.